Okay, so this is a good example on how to find net force. So when it comes down to it, you know that you have 5 kg, you know that you have 20 Newton force to the right, and you know that you have 30 Newton force to the right as well. So we're looking for the net force of this object. Here's what I want you guys to make sure you write down. Understand that 20 Newton to the right is going to be shown as this diagram here. So make sure you jot that down somewhere on your notes. Indicate, because what you're doing right now is you're drawing a diagram to show and explain why and how you got the answer that you will be receiving. So draw this arrow showing 20 newtons to the right by indicating that it is a force, the first force, and you could write under the first force 20 newton. Either one is fine. The next one is understand that 30 newton is also another force that's given that's moving to the right also. Hence why it's in red. So the arrow in blue is the first force. The arrow in red is the second one. So make sure you draw and indicate that too. Because you want to prove that they are going in the same direction. Because remember, it's a vector quantity. The next stage is going to be you being able to add the vectors together. So now, because it's moving to the right is a positive. If it's moving to the left, it's negative, okay? But the right is a positive. So to add vectors, move the second vector so it starts where the first one ends. So you're combining them now. So what's 30 plus 20? Everybody. Exactly. So it's going to be 50. Therefore, when you combine it, and you draw this diagram, the free body diagram is what is indicated. This is a picture. It shows you that you're combining the force of 20 Newton and 30 Newton. Because remember, the overall goal is to find out the net force. Now, I know the net force is given to you, but it's not the net force. I know the forces are given to you in the equation, but you need to find the overall net force, which is why you have to do force equals acceleration equals mass times acceleration. However, because two forces are given to you in this problem, you have to find the total of that in order to find what the actual net force is. So now you have this, okay? Now when this is done, you can go ahead and translate it. So this is important. This is the note I want you to write, because this is you showing that you are adding the sum of the equations together, where the sum of the force equals F1 plus F2. EF equals 20 plus 30 Newton. That's exactly what we just drew. We just drew that. Okay? 20 plus 30. 20 plus 30. And then together you should have 50 newtons to the right. And that is the net. That is the total. That is realistically, because we're not really looking for acceleration. If we were, we'll take that. What are we going to do? If we were looking for acceleration in this problem, what are we going to do with the 50 Newton to the right? Acceleration equals what? What equation will I be using? If the original equation is force equals mass times acceleration, what would I do to find acceleration? Acceleration equals what?
Force divided by mass.
Beautiful. So that when I divide it, then I will have what the acceleration is of this item, this object, whatever it may be. Now, if acceleration isn't given to me, it's probably because the item is at rest and there is no true acceleration besides gravity. And we're going to talk about that. Okay? So let me read that again. Two forces act on an object. One force is 40 newtons to the west. The other force is 40 newtons to the east. What is the net force? What's the total force being acted? It's going to be 0 because it's moving. It's like displacement. When we learn displacement, if it's going to the west, it's going to the what? What side? Positive or negative? What's west?
When it's going to the west, it's going to the right.
If it's going, wait, think about it again. Look at a compass. If it's going west, what would be that be?
Left. It's left.
It's going left, and we know that going left is what? It's negative. Hence why it has a negative 40 north. Okay, and then going to the east is going to be what?
Going to the right.
going to the right, which indicates that the number is going to be what? If I'm going to the right, then the number is going to be what? Positive. And that's why they had 40n plus negative 40n, which gives you 0. Okay, it's pretty simple so far. Okay, if you're going north in this problem, are you going positive or negative?
Positive.
Positive. Because remember, going up means you're going higher in number. It's like acceleration. If you're going down or going south, what would that be?
Negative.
Negative. So if 8 Newton is going to the north and 6 Newton is going to the south, what would be the net force acting upon it then? Or would be the actual net force? If you
and north.
2
and north.
Okay. Is anybody else agreeing, disagreeing? Agreeing, disagreeing? Okay, good. So it should be 2 and north, because north has, and again, think about displacement. North has the highest number compared to south. If it was 8 Newton south and 6 Newton north, then it'd be 2 Newton south. But because north has a way bigger number than south, it becomes 2 Newton north. So we're going to kind of move on. Now, Newton's second law of motion, we already talked about mass and acceleration. Know and understand that mass is a scalar quantity. You don't know what direction mass is going into. You just know that it is what it is. It is what it is. That's how mass is kind of indicated. Okay? Acceleration, however, has direction, because you're accelerating to the right, to the left, up, or down. Acceleration has direction because you know when gravity is acting on an object that's falling, acceleration is in a negative 9.8. Okay? So what I really want you to understand is that mass is a scalar and acceleration is a vector quantity. So back into that example that we had, like I was saying before, like Xavier was telling us before, when it comes down to looking for acceleration, you guys already solved for this. So it's the same problem. You don't have to rewrite it, but you've already solved for this. You know what the net force is. You said the net force is 50 to the right. So when you're going to find acceleration, you should know that force equals mass times acceleration. And like we were saying before, when you flip it, because you want to solve for acceleration is going to equal force divided by mass. That would be the new equation you use. So when you plug in the 50 Newton and the 5 of mass, you're going to be dividing it, because the opposite over here was multiplication. So you're going to be dividing. And when you divide it, you should get 10 meters per second squared to the right, because that's the direction of the force, to the right as the acceleration. Now, the last thing I kind of want to touch base on, and then you guys have time to do your work, is this. This is not confusing, but what I want you to do is I want you to draw this diagram, the first one, and then give a little space for writing, and then draw the second diagram. All you need is a first and second diagram. As I'm explaining it, you can go ahead and take notes, okay? But I want you to draw this first diagram with the arrows going in 3 different directions, and the second one with the arrow going in 2 different directions. I'm going to explain this to you. Let me know when you're ready. So the first diagram, take notes on this, okay? The first diagram is showing you violent motion or violent movement, which means at some point, because there's a force 3, it means that this is a box being pushed. So on this side where there's no arrow, that little corner right here, there will be a person. So you can draw a stick figure there if you like to show that the stick figure of a person is actually applying the third force that you see here as F3. Okay, so all you need to know in this moment is force is a vector, and in this diagram, what it's showing you is there is force going. The first force, which is the natural force. This is exactly what Newton's third law of motion. For every action, there's a reaction. So the first force is a natural force, is what's being how the item isn't breaking down into Earth's crust, so to speak. So if the sun's gravity is pulling on the box, that would be force 1. Force 2 is the actual gravitational pull of the box itself. So take notes on each of these forces and what they mean. You're going to need to know that in the future as we move forward. They will come back to you. So force 2 is like gravity pulling down at the box. Okay, you have gravity pulling up at the box, like the solar system, and you have gravity pulling down at the box, which is gravitational pull. Another way to explain force 1 or force 2 is Newton's third law. Here is the action. The box is pushing down to the ground, so the ground is pushing it back up, so that it's balanced where it is. Force 3 is acted upon by actual person, or of anything that causes a violent movement, like wind, anything in that aspect. Force 3 is showing you that the item is being pushed to the right. That's why acceleration is a vector. Because whatever this box is, whatever is in this box, whatever this item is being pushed to the right with the acceleration of 1 meters per second squared. So it's not moving as fast, but it's moving. Now the second image shows you that there is no acceleration, just gravity's acting upon it. So this item, the first image, this one, the item is in motion. It's being moved. That's why there's a force 3. The second image, this one, the item is at rest. So it's almost like a book that's just laying on a table. Understand, for every action there's a reaction. So force 1 is the natural force, and force 2 is gravitational pull. It's the weight of the item, whatever it may be. Now, there's an equation on the right side where force 1 plus negative force 2, because negative force 2 would be negative 9.8 if it's gravity, equals mass, where acceleration doesn't count because it's not moving. There is no direction it's moving at, so there is no acceleration. Does that make sense?